This conference will now be recorded.
So we have learned in yesterday's class how to implement this one, right? How to implement, we have learned, right? We have learned so far how to implement a simple neural network, right? A simple neural network. So what simple neural network contains? So here your input matrix means input layer, right? 2 hidden layer, and 3 output layer. These are the things that we have learned. So what makes a deep neural network? Deep neural network. So what is the difference between your actual machine learning and a deep learning? What is the actual difference between your machine learning and deep learning? In machine learning, you are just applying a connection between your x values and y values through a one function. Through a function, you are applying a connection between your x and y values. But in deep learning, what you are doing, you are adding a layer, right? You are adding a layer and you are calculating the weights, okay? Not directly. That means in your machine learning, your weights will be is going to be a your weights will be helps us to calculate the predicted values. But here, not just with the one direct weight values, you are adding in between hidden layers and input, and in between your hidden layers and output as well. So multiple weight values, because of hidden layer construction, you are adding a multiple weight values, not with direct weight values. 2 times you are adding weight values with one hidden layer. Right now, that is what we are learning. And 2 times you are applying functions. So that is what the complexity of this measure. Okay, and that is the first difference. Now, like not as example, if you are working on some other different examples, you may see how many times you made a repeated iterations. Like yesterday's case, I mentioned as 100 epochs. That means what? 100 times I'm asking for construct this loop. Deep learning having largest data. I'm not talking about the data, how much we are taking inside of my examples. I'm talking about the concept of how it actually works. Okay, I'm not talking about the largest data here. So come back. So what I'm talking now, yeah, when I'm making the 100 epochs or 1000 epochs or 10,000 epochs or 1 lakh epochs, maybe in some different example, you may not improve the accuracy. You may not get the accuracy as you expected. Maybe your accuracy is still at 80 or 70, or still fighting there. You are fighting with the accuracy still at that moment. You are not able to improve the performance. So in such case, what shall I do? In such case, what shall I do? That means you are failure in terms of all your machine learning algorithms, and you are came for to apply deep learning, and this deep learning again inside simple neural network is not giving any solution. Even you make 1 lakh epochs or iterations, whatever you do. So what shall I do now? That's the question. In those cases, you need to go for the next level of your neural networks. Okay, in that goes, you need to go for the next level of your learning. That is what here deep neural network. So what deep neural network will do? Input layer, that will be there. Okay. So here more than one hidden layer. More than one hidden layer required here. And output layer. So why I'm mentioning as more than one hidden layer means what? It depends upon case to cases. Yeah, you may choose hidden layer 1, okay, 2, again hidden layer 2, like 3, hidden layer 3, and it will be so on. Understanding when we'll call as deep neural networks. So that is, so it can be added, that depends upon how much. So it does not mean that you will add 100 hidden layers inside. Don't go that much up level. It will become very high complex. So maximum you will get the accuracy between 1, 2, 3 and hidden layers only. So between 1 to 3 hidden layers only you will get the most of the results. No need to go for 10, 15, 20. It will become too much complex and you don't know what you will do. What is happening also you will confuse. Your system will be hanged out if you make too much complex. So you should not go too much of, yeah, your system. I mean, your program is there, your packages are there. It doesn't mean that you make it whatever you want. All right. So most of the cases with 3 or 4 max, maybe it will be closed. Your issues will be resolved. It should be resolved. However, so the coding will be same. Everything will be same. You need to write an extra layer. I mean, in yesterday's example, where is our example? SNN2, this one. We finish here. Yeah, so if you check here, hope you are able to see the screen. Yeah, if you see here, this is the line layer 2 we mentioned. Na? You need to, I mean, you need to add up another line. Code, everything is remaining. Nothing changed. Remaining, all the functions are same. Only you need to add up this line an extra layer. That is the thing that you need to cover. Just a minute. Yes, guys. Hope you are there. Ipna, come back. Yeah, it was open. Now it will. I'll open this. Yes. So what I'm telling here is you need to add this line like one by one. You need to keep on adding few more lines. Like that, you can add any more line, n number of lines. So that is the difference. So you can try with any example and look for the higher accuracy. If you are not meet your accuracy, if you are meet your accuracy, then no need to worry. If you are successful in the first attempt only, then no need to do, no need to go for the deep neural networks. If you are not get the accuracy, then you can try. That is the only way. All right. Yes. Now let's go for the next one. So we learned today convolutional neural networks. So what is this convolutional neural networks? So when we'll apply this? So till now you have learned all your structural data, right? So basically what I told always, structural data, unstructural data. Structural data, unstructural data. This is what we have. So structural data is the things that we are learned. In unstructured data, we have covered what? One is if I have textual data. So how did we cover this textual data? We applied natural language processing. Right? This is what we're learning. And what is if I have unstructured data and that should do that is unstructured and that too not like your regulated. So what is your not like your regulated? That means your image data. If I have an image data, so how should I predict it? How should I work on algorithm? Understanding what I'm talking? So let's say the examples for this kind of situation is like nowadays if you see we are getting such a apps in your mobiles. My app will okay, your phone app will try to predict whether the person is a male person or female person. Hope you might be seeing this kind of apps anywhere in your existing phones. If you are using such kind of apps, check out your app will. Few more examples like I think Facebook or some other things. So what they will do? It will try to predict your age. Have you noticed this kind of scenarios in your previous learnings? I mean, previous. When you are playing with your mobiles or when we are using Facebook, have you noticed this kind of examples? So how it was happening? How your Facebook is trying to predict your age. It is also trying to predict whether the person is a male or female. How your such kind of mobile applications or any other apps is trying to predict the thing is. So that is what we are trying to learn here. How it was recognition, how the facial recognition is happening. How the facial recognition is happening. Whether the person is a male or female. Understanding what I'm talking? So here we are passing out not your regular kind of data, we are passing out an image data. That is the difference. Understanding? So how it is going to be happen? So there is a lot of things are there here. Okay. So here in this travel, CNN contains, yeah, computer vision. So what does it mean by computer vision? Your computer should be able to identify what actually uh, what are the features that you have passed inside. Your computer should be able to predict. Okay, image recognition. Yes, that is what I'm talking. So we are in such a technology nowadays. Your apps are trying to predict that image or any other things. Okay. So if you see, this is one more example. Some more examples like object detection. How an object will be detected? If you see some examples like self-driving car, how a car can be driven by itself? That is the question first. How a car can be driven by itself? That means what? A programming thing is happened inside of the car. Now the program will auto start its engine and it will start works. So whenever it is having some rules, it will follow some rules, and whenever suddenly something is, I mean, whoever comes on the road and automatically it will control its brakes. It will take, if it's required, it will take left or right direction, and it will keep going on. So how it is going to be happen? That means what? A scanner will be there inside of the car. Those scanned machine will be taking up the images to try to detect, and it will transform into an information into that program, and that program will calculate the values. What is, I mean, what object is in front of my car with how much of distance and how much of speed to be controlled. So these all things going to be happen in fraction of seconds. Have you ever thought about this kind of, I mean, application, how it was actually working? So these all the examples of your deep learning only from the CNN or reinforcement learning. So what is reinforcement learning? That is what we are going to talk in the next classes, in the coming class, maybe in the next week. But before going for the reinforcement learning, first you need to digest what is actually these all things. Okay. So yes, sometimes even you could have seen some apps like now based on your inputs, yeah, it will try to predict whether the person is feeling happy or sad or angry or no expression. So these all those examples. These all those are examples of your CNN or RNN or any other one which is in a reinforcement learning structure. Okay. Yeah. So how an image will be transformed? That's the question is now how an image how an image will be transformed into numbers. How an image will be transformed into numbers? That's the question. Okay. So in this explanation, so you should get, first of all, you need to understand what are actually pixels. Have you heard about this word pixels? You might be, when you are purchasing a new mobile phone, you might be heard about 32 megapixels, 64 megapixels, 42 megapixels. Why we looking for such pixels? Why we looking for such pixels numbers? If we have high pixels, that means what? Your pic, whatever the photograph that you will take, you will get more clarity, no? But we never understand what actually the pixels is talking about. Okay, so if we have an image in front of you that contains some x number of pixels, understanding? Take any image, not hard copy. Okay, I'm talking about any soft copy. Okay, that contains some number of pixels. Which lens that you have made use to take out the picture, that makes the best quality. Huh? If you take a normal long back phones, you may get 10 12 pixels. Like say, you may have, I mean, not much high clarity. Nowadays, when you are using high number of pixels, you are getting best quality of output. All right. If I take some example, see here. So we have different shapes, different angles, huh? In these images, not all same, right? Not all are same. If you see here, this one is like, you know, a lengthier one. I mean, it was a tall kind of shape. If it is look out here, it was, you know, more width. It contains more width. This looks like a square piece. Agree? Few of the things are right. This one is completely rectangle shape. Most of them rectangle only. So each photo we had different shapes. One is yeah, I mean, like the longest one kind of pic. One is more width kind of size. One is a square kind of size, right? If you click on it, if you see here, observe here closely where my mouse is there. Have you seen 1200 by 900? Have you noticed this number here? 1200 by 900. So what does it mean? This image contains 1200 by 900 pixels. Understanding? Today's topic is more interesting. Okay, keep listening. So 1200 by 900 images, sorry, pixels are there in this one specific image. So what is pixel? So if I make an equal sized parts, listen carefully, 1200 into 900. So how much the value will be actually? 12 nines are 108. That means 1,08,000 parts, small boxes, squared pieces. If I make 1,08,000 squared pieces of this entire image, so how does that parts looks like? Very small, no? Very small. So each one part is going to be 1 pixel. So like that, in this entire picture, I have 1200 into 900 pixels. So 1200 is the width size and 900 is the uh, length size. Yeah, length into breadth size and length size. Yes, like you can talk like na x-axis, y-axis in our language. So this entire image contains this many number of pixels. If I click on another image, again you will see a different number. Look out here. How many? What is the pixel size here? Have you? I don't know whether you are able to see these numbers or not. Can you able to see when I click on image at the bottom near my mouse? Can you identify? It is very small actually. You are able to see now. Very good. So 2000 by 3008 number of pixels are there. So you can imagine how much of small particles are there. Like that, even if you look out for your LCD TV or LED TV, people will explain how many pixels of the quality of the picture it will comes out. Okay, so each image will have a different size. That is clear. Now what we are going to do with this? That is the question. So these are what pixels. You have seen what are pixels, that you are understood now. Okay, so what we are going to do? So generally we will have, we know how many colors contains, what kind of photographs we have generally. Most of the people are known that we will have black and white, Okay, and car photographs, color pics. These are the two things that we have generally, right? But apart from that, before black and white, we also have gray color pictures. There is a difference between gray color pics and black and white pics. So your computer will treat these two types of pics individually. So your computer will treat them as gray color pics. Whenever you are passing a gray color pics information to your system, it will treat them into what? Two-dimensional size. All right. But whenever you're passing gray color pics, it will treat them as two dimensions. Whenever you are passing black and white and color pics, it will consider as three-dimensional size. Let me write like this. Okay, 3D size. Understanding? So there is a difference between gray color pics and your black and white pics. So your computer will recognize those difference, not by us. We can also, if you try to look out, you will get an observation few of the things, but almost looks same. But computer will treat them in a different way. Any computer, okay? So this gray color two-dimension means what? So how does a two-dimension looks like? So you have a values. In generally, how the values will be captured. Now, first of all, you should understand how values will be captured. In your computer, always, okay, there will be values captured between 0 to 250. That means what? Computer will realize that each color will have a number. Computer will take each color with a number to understand by itself. Okay, if you see here, when we are using this MS Word document, okay, when people write anything, when you click on it, now you will see more colors. Now, if you see here, generally we have two things: standard and custom. When you click on custom, you will see what? An RGB dimension. So what is this RGB? Oh, totally gone into this. 1 second, guys. It is not coming. Okay, so just a minute, guys. Put it here. So when you change this one, what is this RGB? Na? So what is this RGB? Here. RGB. So R stands for red, green, blue. So overall, it will be converted. I mean, it will captured into three dimensions. That means what? Each dimension will take the values of each color. Red, green, blue colors are actually three dimensions will be captured at the back end. So when you look out here, you will have many more colors. When you change, look out here, I am using the maximized color, which is 255. After that, it is not getting improved. When you go back here, 0. So if you see, the color becomes completely dark. Understanding? When I try to improve these colors, When you try to improve these colors, it is a mixture of elements that is coming up. Understanding? It is talking about current. So from current color to, so that means what? When I open the image contains different multiple colors. So in each pixel will definitely there will be some color will be associated with that image or not. In each pixel you will have some color. So when you have some color, that means what? There is some value in the backend. Computer will take those values of that every pixel. Understanding what I'm talking? So here also each color, yeah, the percentage of information that you are passing out into the screen will, if it contains more red color information, so those will be saved into the one axis. If you are passing the image contains more green color information, so the values will be stored in the second dimension. Like that, if you are passing the blue color information more, those will be values will be saved in the blue dimension. Is it clear what I'm talking? So each image will have a multiple colors according to the color which are in the image, and it is in pixels. Those values, what actually computer will take, those values will be saved in the backend memory, and we are trying to pull those values for our mathematical calculation. Understanding? For example, yeah, when I'm talking about a black and white, gray color board, I have taken one image, okay, and the values are like this: 0, 0, and 2, and 2. Now this is my image. This is in gray color mode. So what is the dimension of this image? What is the dimension of this image now? 2 by 2. Right now, dimension of this image is 2 by 2. So obviously, yeah, you have the values as 4 values. Finally, you have the values. If I take a colored image, so what is the dimension it will be now? You will have 3 sets of these things. You will have 3 sets of these things. Understanding? So let's give some values. 1, 2, so 3, 4, 5, 6. Just imagine that it is a step. I mean, this total. Yeah, I have taken a colored image. Okay, in that we have three dimensions. So each dimension will have some values like this. Actually, the image is like this: a simple square image, which contains a few colors. Okay, some of red, some of what do you say? Some are green, some are blue, something. This is my image. So when I transformed this image, my computer has gathered that, yeah, here this set contains totally some number of pixels. Okay, I'll come back to the part how many pixels, some n number of pixels, n by n. Okay, and if I split independently, I got red colored values as like this. Okay, green colored values are like this, and blue colored values are like this. So if you can imagine that red contains, yeah, some 30% information, green contains again 30%, and let's say blue, of course not blue here, yeah, blue only, blue here, but let me write as 40. Actually, let me put this one as 40. It is more closer now, and blue contains 20. Why? Because red and green is more nearest to your yellow and red. Okay, red and green is more nearest to your yellow red. So that's why I given as 40-40. So these are the actual percentages. Percentage of color in my entire pic contains. Clear? Blue is very, very less, so I given as 20. Percentage of information, not values. So when I made independently, separately, and I received these values. And I received these values. Now, in the entire 3 dimension, now I need to calculate the total number of pixels. So what is the pixels? So how many, I mean, in each color, what is the size? 2 by 2. This is 2 by 2. This is 2 by 2. This is 2 by 2. So finally, what should be number of pixels now? 2 2s are 4. Okay. And 4 into 3, 12 number of pixels. Understood? This is 2 2s are 4. So 4 plus 4 are 8. And 8 plus 4, 12. So totally 12 number of pixels. That means what? Here you can imagine like it could be a 3 by 4 size or 4 by 3 size. There are many possibilities. Huh? 3 by 4 size or 4 by 3 size or 2 by 6 size or 6 by 2 size. Agree? I just mentioned as a squared color piece, but you can imagine whatever the number. Was not able to hear me. If my sound is not appropriate, Sindhu, Pallavi, are you not able to hear my voice clearly? I could see signal is complete good here from my end. I don't have any signal issues. It is good now? Okay, good. So in my previous example, when I googled it, what is the number of pixels that we have seen there? Some 800 into 900. So imagine how many number of pixels in that image contains. Right now? So what we are going to do with these pixels? Now, so I am talking about one image. Right now? One image. When I pass one image to my system will convert image into 3 dimension first, okay, and then from 3 dimension to it will take the values of according to the colors, and then it will assign the values according to the image and its colors. It will assign the values at the back end. You are not going to do anything. Your system will take care of assigning those values.
Sir,
Once you have done, once your values are saved at the
hello.
back end. Hello?
Sir, this is Shivani.
Yeah, Shivani, please speak out.
Hello. Sir,
Hello,
can you please
Shivani.
explain again? The audio is off for 3 minutes. Please, sir, can you please explain
Okay,
again?
so till now, where you understood till now?
RGB, this thing, red, green, blue, you wrote, no? So
Yeah.
40%, 40%, 20%, till there.
Yes, yes, yes. Okay, so let me repeat again, no issues. What I'm talking is, so this is percentage of color it contains in the image. Now tell me, I clicked on this page. Yeah, this one is very nice. I clicked on this page. I'm talking about the right side image here, what you are looking. So can you guess what colors it contains? All the 3 colors, RGB. So green we are not able to see because it is where you see in the plants or grass, huh? That's all covered green percentage. So red color will be under like your lights, okay, and remaining is blue percentage more higher. So what is the percentage of blue color? What is this picture contains how much percentage of blue color? Almost 80%, no? And remaining 10% is green, and remaining 10% is like red. That is what actually it is capturing. So this example also I'm talking, it is similar direction. which I taken as peak above, I given as red contains 40%, green contains 40%, and blue only 20%. Now clear? Now what I'm talking is, let me write into words. Whenever we pass an image to system, okay, your system will transform, okay, into pixels. That means what? It will create a, first of all, it will try to understand it's a black and white or color or grayscale. It will identify it first of all. Once it is identified, so it will put those image values. That means your pixel values. Your system will transform. It will create. Let me put it right way. It will transform. Yeah, your system will transform into values from the color given. From the color given. So what colors it contains, based on that it will transform a values, the way which I am talking about. So in my image, I may have red color, blue color, green color, any other color. What, based on the color combination? Based on the color combination, it will assign those values. And if you are passing a color, what happens? It will create such a three-dimensional values from the color given, and it will save into a three-dimensional data in your system memory. Alright, and it will be saved in three-dimensional data into your system memory. Now what we are going to do? So here I am calculating, yeah, the number of pixels. So here also this yellow or red color pixels, I have the values are like this. I have the values are like this. So I would like to calculate the total number of pixels are how many. So here in each dimension we have 2 by 2 set. Like that, how many sets we have? 3 dimensions. So 3 sets. So 4, 4, 4. 4 3s are 12. That means your image contains total number 12 pixels. Like that, in your Google page, this image, this blue color image contains 919 into 513. That means what? 919, 513. This image contains how much it is? 4,71,447 pixels. Can you believe it? Can you believe it? This image contains so many number of pixels? Yes, you should believe. Now it's clear what I'm talking. Now when I'm talking about one specific image contains this many pixels, imagine how much bigger. So what we are going to do with this? That's the question. What we are going to do with these pixels? So till now you have learned. Yeah, when I pass one image, I could see these many numbers. So let's come back. I'll come back to that point again. Let's take this example which you are talking. So I have 12 pixels. So I have 12 pixels. So this 12 pixels, I will convert into a flattened. So here, for example, I have an image like this. So I need to work on this image now. So I use some logics, okay, and I'll convert this image into a flattened shape. So what it becomes? So here it contains 3D data. That is what we are seeing, right? 3D data. So once it is converted, now values will be transformed into like this. So how it is going to be happen? Yeah, 0 1 0 1. 1 second. If you put it in like this colors, you will get to know red color, RGB. This is green color, and this is blue color. Understanding what I'm doing? Now I'll put all these values into like this. It's side by side. First row is done. Second row will come beside of it. Again. Hope you are able to follow what I'm trying to do here. All right. Yes. Now when I pass one image, so totally how many values it is converted into? It is converted into 12 pixels. That means what? My image contains 12 individual columns. Now this is going to be your x1 underscore 1. Yes. How many columns we have? 12 columns it is generated. Is it clear? Now I'll pass the second image. So I don't know. Second image could be what? Second image contains either more number of columns than previous, or less number of columns than previous, or same number of columns. Understanding? Now this time, first image I sent as one different angle of your Eiffel Tower. Second one I will pass as some other different image of same different. I mean Eiffel Tower only. Or else you can think any other image, whatever. So it does not mean that every image will have a 10 pixels, right? You may have different pixels. So you may have, now this time 14 pixels I received. It is not the proper number actually, but let's imagine 15. Let's take 15. 3 into 5. Once I flatten it again, so definitely your values will be like this again. This time I need to get extra value, no? A new value will be created because I need to get 15 values finally. Yes, I think now it's 15 values. Count it. It should be. Understanding? Again, third image. So third values. So this time I received only 9 values. That means the image pixel is the image is very small size. Okay. So what happened? Yeah. So I have only like these values: 1, 2, 0, red color, and some green color, and some blue color. Understanding? Because every image is not going to be the same size, na? Each will have different sizes. What you are going to do with this? Yeah, you are trying to, if you have target variable like this, y, let's identify that whether it's an object or human being. Clear? I have two kinds of classes. 1, 0. It's a human being, or it's a normal object, any object, not a human being. Clear? So my first image is a object, that is 0. Second one is actually a human. Third one is again an object. Understanding what is happening? That means what? I am trying to take an example of whether it is a human being's image or it's not a human being's image. So my values will be like this. So my image have different values here. Okay. And what happens? And each image contains different number of pixels. So here I have till x underscore 15. Na? So what will be assigned to the remaining values, remaining places? Whichever contains highest number of pixels, though on those bases it will calculate the number of columns, and remaining values will be automatically will be taken as zeros. Understanding what I'm talking? So this is going to be happens. This is how your image values will be transformed into pixels first, from the pixels to numbers, then you are going to construct again what, an ANN network in between your X and Y. That makes your convolutional neural network. Still not yet finished, but I'm just telling you the story. Have you understood what is going on here? So you need to concentrate is how an image is transformed into pixels, and pixels are in the 3-dimension. So 3-dimension, how it will be converted into flattened, and this flattened makes us actually the number of columns. Once my number of columns are created, now I will put with any of the machine learning or any other deep learning. You can apply machine learning also, but your accuracy will be very, very low. Why? Because when it is a high dimensional, why I'm telling us high dimensional? Look out here. In the previous example, how many columns we created here? I mean, the Eiffel Tower size 919 to 513. So how many columns, how many pixels are there? 47,000, sorry, sir, 4,71,447 pixels. That means what? 4,71,447 columns are going to be created. So when you have this many number of columns, will you apply machine learning here? You cannot apply machine learning here. So you need to apply your deep learning again here. That means your deep neural network, your artificial neural network, anything that you need to apply on here. That is what you are going to learn. So in the real time, when you pass an image, your number of columns will be in lakhs, not just like your numbers. Here I made you show an example with to make you understand with the 12 columns. But in the real time, your number of columns will be in the lakhs. Is it clear, everyone? So to get into this flatten, to get into this exercise of flatten, you also require to learn few more things. Few more steps are there. So what are those steps? How to make flatten? That is what you are going to learn in the coming class, tomorrow's class. So tomorrow also you are going to learn some theory. Maybe day after tomorrow also you are going to understand some more advanced theory internally. Then after that we will go for the code, how to write this code. So again, don't worry, everything we have package. Package will take care. But you need to understand how the calculation is working here. That makes more complex here. All right. So okay, guys. So any questions from your end? Okay. So no, na. So let's meet up tomorrow, same time. All right. I'm logging out.